In this screencast, we are looking at the sources of greenhouse gases. And the source can be a natural one or an anthropogenic source. So we'll look at each of the sources, and we'll also think about quantities and whether it has changed and is affecting our current environment. So we'll start with natural sources. There are volcanic eruptions, and when there's not a volcanic eruption, there's a lot of carbon dioxide put into the atmosphere. And there are also other particulates and things like that. But basically, the gas that we're concerned about is carbon dioxide. However, this is typically a temporary effect. For example, when Mount Pinatubo exploded and erupted in 1991, there was a lot of atmosphere, a lot of ash, that went into the atmosphere, and a lot of CO2. But the overall effect was that the temperature decreased only by 0.5 degree centigrade, and that's 0.9 degrees in Fahrenheit. And the effect was temporary. Very quickly after and this was a large eruption, very quickly after the eruption, the atmosphere returned to normal temperatures. Well, quote, normal temperatures. Okay, decomposition is also a source of the greenhouse gas methane. So whenever you have areas such as wetlands that don't have a lot of oxygen, and there are bacteria which break down the organic matter that died in this area, in this wetland, then methane will be released. Another natural process is denitrification. And if you think back to the nitrogen cycle, discussed many chapters ago, the nitrogen in the atmosphere, N2, cannot be used by plants. So it's converted by specialized bacteria into a form that plants can use. But during this denitrification process, nitrous oxide is a byproduct. And nitrous oxide is an agent which is a greenhouse gas. And last but not least, the water cycle, of course, completely natural. There's large amounts of water which act as greenhouse gases, and when they are atmospheric gases. So these are all natural. Now let's look at the contributions from anthropogenic sources. That would include the burning of fossil fuels. So when you burn gasoline, when you burn heating oil, when you burn methane for heat, then you are creating additional sources of CO2 and methane. And let's not forget too, the extraction of fossil fuels can also result in the accidental release of methane, for example. Agricultural practices are actually huge. There's the not as huge contribution from the method of irrigation where the crops are flooded, but then again that results in anaerobic decomposition, and that can lead to methane. But even greater is the effect of farm animals such as cattle. I don't know how much you know about cows, but they not only fart, they burp a tremendous amount of CO2 into the atmosphere. And so the more our agriculture relies on animals that produce CO2, then the more CO2 is going to go into the atmosphere. One thing I didn't mention on the previous slide about natural release is that there are things like termites, for example, that also release these atmospheric gases. And that's normal. That's part of the natural cycle from their digestion, but mainly we're talking about a huge number of cows releasing these atmospheric gases. Okay, next we have deforestation. Deforestation, as you recall, is the cutting down of trees. And this leads to greater amounts of CO2 because you can have, the trees would normally take up a certain amount of CO2, and once they're deforested, they cannot do that. Next is landfills. As you probably recall from the landfill chapter, both CO2 and methane, mainly methane, are released from landfills because of anaerobic digestion of bacteria that are digesting the trash. And then last but not least, we have industrial production of chemicals such as the CFCs. Now, the CFCs were banned in developed countries, as we've discussed, but they were replaced with another chemical called HCFC. And HCFC does not destroy the ozone layer, so that's why they were chosen as a replacement. However, they are a greenhouse gas. It is a greenhouse gas. And so it is in the process of being phased out of developed countries, and the goal is by 2030. So now let's look at which greenhouse gases are released from each of the following sources. So these charts look at the several greenhouse gases, methane, nitrous oxide, and carbon dioxide, and look at the sources in the United States where these gases are coming from. Okay, and this is according to the EPA, and the charts are a little bit confusing, but not entirely. So let's look at methane, or CH4. You can see livestock digestion is the source of almost 1/4 of all methane produced, and same with landfills, only slightly less. Next, we have natural gas and petroleum, coal mining, manure management, remember those manure lagoons, a little bit from combustion and rice cultivation, and then other. So it's no surprise that we would want to target livestock, landfills, and using of natural gas and petroleum to reduce the amount of methane that's going to be added to the atmosphere. If we look at nitrous oxide, we can see that the vast majority, almost 70%, come from agricultural soils. So why so high? That's because nitrogen is added as a fertilizer in higher numbers, in higher quantities than would normally be applied, because it is a limiting nutrient. And so that nitrogen fertilizer that's applied eventually becomes nitrous oxide. And then again, there's small other contributors such as combustion, nitric acid production, manure management, and other. But mainly we would want to target or focus on the amount of fertilizer being applied to agricultural soils to reduce the amount of nitrous oxide that is going into the atmosphere. And last, we have CO2. So this chart is a little bit misleading because it's a bar graph, but fossil fuels used for energy constitute 94%. So if that was on this graph, that would be somewhere like over here, right? Way far over. And the next runner up here, fossil fuels not used for energy, is only down here at 2.5%. So clearly the focus for reducing CO2 going into the atmosphere would be to reduce fossil fuels used for energy. It might be for home heating oil, it might be for natural gas for heating and cooking. Any of those can well, actually not natural gas, but any regular fossil fuel burning, such as gasoline, will result in a lot or most of the CO2 that's going into the atmosphere. So a very simple thing to target. Okay, now I'm going to actually pause it here before we talk about climate.